We will continue our last session for stiffness matrix. We explained this one, the stiffness matrix, last session, and today we will further explain this one through a numerical example. So this is the example. Calculate the displacement and the forces developed at node 1, 2, and 3 for the stepped aluminum bar shown in the figure, which is free at node 1 and fixed at node 3 for the following data. Element 1, the length, L1 is the length, 0.42 meters, and A1 is the cross-sectional area, 150 multiplied by 10 to the minus 6 meter squared. The same thing for member 2 or element 2. The length is 0.56 meter, A2 2.240 multiplied by 10 to the minus 6. The modulus of elasticity, it is 70 multiplied by 10 to the 6 kilonewton per meter squared. So the solution is, okay, for element solution, calculate the displacement. So the first thing is to calculate the stiffness calculation. The first is element 1. It is this one. So for this one, I need to calculate first EA over L. And this will be E. It is 70 multiplied by 10 to the 6 multiplied by 150 multiplied by 10 to the minus 6 over L. L is 0.42. So this will be 25 multiplied by 10 to the 3 kilonewton per meter. So this is the stiffness for element 1. For element 2, EA over L will equal to 70 multiplied by 10 to the 6 multiplied by the area of element 2. It is 240 multiplied by 10 to the minus 6 over 0.56, and this will be 30 multiplied by 10 to the 3 kilonewton per meter. So now the stiffness for element 1, stiffness matrix. Stiffness matrix for element 1, the stiffness matrix in general, it is like this. EA over L minus EA over L minus EA over L, EA over L. So the stiffness matrix for element 1, EA over L for element 1, it is 2.5. So the stiffness matrix, it will be like this. Here it will be 25 multiplied by 10 to the 3. Here it will be. This is for element 1. So this is stiffness matrix is for element 2. For element 1. For element 2, the same thing I'll be using. It will be okay. Now, after I obtained the two stiffness matrices, now I can assemble the global stiffness matrix, which is the combination between this one and this one. Now, if I do this, I will have the global stiffness matrix. It will be like this.